Okay guys, so this is my machine after the last upgrade, and I showed you how I cut this piece of aluminum on this machine, and I wasn't really happy with that process because even with the new spindle it wasn't cutting very smoothly on this piece, and it also break one flute on my bit here, so I was really disappointed after analyzing everything, and I think that problem coming from these two rails on the x-axis because they are long and they are not fully supported, so they are pretty weak. They bend very easily. If I do this, I can feel that the whole z-axis here just moving back and forth, so that is not good for aluminum cutting or cutting anything. So what I decide to do, just I will replace the rail with this type of rail, just a fully supported SBR 16 400 millimeter length. I got a set of two of these with 4 linear bearing block here for only $30, so it's very reasonable. So let me just show you what I need to do or change on the computer first, and then I will show you how I put the whole thing together. Compared to my last upgrade, the machine didn't change much in the look. The only thing just really changing are those two boards. Just they are SBR 16 now, so the linear bearing block have to change with them, and because of that I will have to change the z-axis back block. So I also take the chance to make this plate thicker, 19 millimeter, so it will be more sturdy, and I also have to remake this stepper motor mount and also the holder for the bearing to support the end of the T8 leg screw. I made them a bit wider so they will act as stopper to stop the linear bearing block from slide out all the way. Here at the back of the machine I will need to trim these three bars to length of 91 millimeter or less, so I will cut them about 90 millimeter. Because I will upgrade my machine from my last rebuild, so I only need to remove this plate, this one, and this piece. Other than that, not much else. So I just going to show you how I install those two bars and also how I re-put together the z-axis block. That's it. Okay guys, so I think that I have everything here to put together the new setup for this machine to be able to mill aluminum. So I have the two rail with the bearing blocks. I have the new back of the z-axis block. I have all the small pieces here milled, and I also have the three pieces of the aluminum extrusion cut to 90 millimeter length. So now what I need to do next is just take out all the wires and everything. So transfer the z-axis block here to this plate, and then just replace the rail here with these rails. That's about it. Okay, so after my last upgrade, I took some time to redesign the back here, just arrange all the components and everything looked really nice and tidy. But now I have to take them apart and remake some of the plate here to restore them back on. So yeah, it hurt me a little bit here, but I have to do it. You won't need this two rail anymore. Maybe you can use it later for something else. Maybe I will replace those small rail on the z-axis with those rails, but I will do it later. Okay, so the next step is to install the Z-axis block back together on this plate. First step, I just have to install this piece of nut housing on here with this like 12 or 13 millimeter spacer. Okay, so the next step is to install the linear bearing block on this, like this. Okay, so now I can install the rest of the Z-axis on this. So now I have the Z-axis block all back together. The next step is to install the rails and put this on the X-axis. Okay guys, so I ran into a bit of problem here because of the distance of the hole here are fixed, and if I use the big corner bracket here, 28mm side, I wouldn't have any space to install this board, so I can install like fix this hole on this board. So I will have to use the smaller one, 20mm side here. So that way I will have just enough space to install the bar here and fix this hole on this bar. Okay, so I'm just going to start with this bar, install all the way on top of this. Okay, so now I have this bar installed on top. The next step I just going to install this bar like this. Okay, so I ran into another problem to install the rail on here. It's just the drop-in nuts are only M5, but the holes here are 6mm. So if I use the M5 bolt, they're not going to be centered in the hole. So I will need some type of spacer in here, 6mm to fit into those holes, and the inner diameter will be about like 5mm. Okay, so my solution for this is using the plastic tube 1/4 of an inch outer diameter, so 6.35 millimeter. If I try to force them, they still can go through the holes here, so I can still trim them. Though inner diameter is a bit smaller than M5, but if I try to force them in, they can still make the thread and go through. So that's what I'm going to use. Okay, so now I have all the nuts just pre-installed on here. I just line them up like this and put them on here. Okay, and I kind of line up the edge here to the edge of this bar, and then just lock the nuts in. Okay, so the next step is just I just want to slide this Z-axis block on this rail like this, and then take this rail, just slide underneath. Okay, so it will be just like this, and then I take this bar, just fix it at the back of this, at the lower row. Okay, so now from the back of the machine, I just need to fix the corner bracket here to fix this bar on the frame. The next step, I just take this piece and slide them in here, and then just lock them with the nuts here. And then just fix the bar with some of the corner bracket like this. Okay, so now the rest is easy. I just install the piece on here, the latch screw, and also the stepper motor. That's it. Okay, so now everything is back on. This is really sturdy. It doesn't have any type of movement, even if I try to push it. So I think this is it. And next step, I just going to reinstall the spindle clamp and the spindle and rewire everything and show you the test cut on aluminum. Okay, so I have everything put back together, like wires and everything. It's really sturdy, nothing really moving. So let me just show you how it's moved in all axes. Okay, so as you can see, just everything moves really smoothly. Now I just going to do a face milk of this wasteboard, and then I will show you aluminum milling on this setup. The face mill with the 20mm bit went really smoothly, so I'm very confident with the aluminum milling. Last time I broke my 2mm bit, so this time I just going to use the 3mm bit. I'm very confident that it will go well this time, so I just going to go very fast. The feed rate will be 500mm per minute, and the maximum step down is 0.3mm. The plunge rate about like 40 to 60mm. So let's see how it goes. As you can see, just it cut a lot better compared to last time. I go really fast, but there's still some kind of rumbling sound. I think I went a bit too fast. Maybe 0.1 or 0.2mm step down with 400mm per minute feed rate will be a lot better. So let me just try another one. So with 400 millimeter feed rate, 0.15 millimeter step down, and 40 millimeter per minute plunge rate, it's cut really good. So I think that's it. I don't think that you should go any faster. Maybe even go slower if you want to be safe and cut really smooth. But I think just this is my parameter. So okay, so in the end, to summarize the aluminum milling on this machine, if you want it to cut really smoothly and safely to save your bit and everything, you should upgrade the rails on the x-axis to like fully supported type of rails, and also the spindle to something powerful like 400 or 500 watt motor. So those are the most important upgrades that you need to do to cut aluminum on this type of machine.